All right, so basically what we have is games.resty.com. Below that URL in case you want to go there. So this is just a server implementation of the game of Tic-tac-toe, and there's a few links on here that will be really helpful for getting you started. Mainly this read the Tic-tac-toe tutorial. This, if you read through it, is just basically an example of a game happening, and it will highlight for you each of the messages that you send over the WebSocket and that you receive from the WebSocket and what each of the things in those messages mean. So this is not super long. It's probably like 1 or 1.5 pages if I didn't blow up the font humongous. The main things you need to know about is every game happens in what's called a topic. I'm using a WebSocket system that already has some semantics, and so I just am reusing their semantics. So a topic is basically a channel, so everyone that joins that channel will get a set of messages. And so that's called a topic, and every message that goes to and from the server will have a topic in it. This is because you can actually join multiple games from the same WebSocket and be involved in multiple games at once if you want. Then each one of them also has an event. This is just kind of like a type flag. It's just always some string, so it could be something like, one that you'll see a lot of is you'll get these state messages like this, and that means that the state of the game has changed. So something happened on the board, and whose turn it is has now changed. The server will broadcast one of these messages whenever that happens. Then there's a ref. If you every time you send in a request to the server over the WebSocket, you might be getting other messages in the meantime. And so a ref is just some unique identifier that you generate to say, hey, please add me to game whatever. And when it responds to that, it will put that same ref in its response message so that you know how to connect the two. Probably doesn't matter for most of what we're doing tonight. And then finally there's a payload, and the payload always has to be a JavaScript object. It's never going to be just a number or a string. It's always going to be an object with keys and values. And so the messages end up looking like something like this. You basically send in a phx join, a Phoenix join message, and you provide a token, and the token is just some unique string that represents you. This is just basically so that your opponent can't play on your behalf as long as they don't know your token. Your token never gets broadcasted on the channel, so hopefully you're not just playing as each other and cheating, although, good strategy. And then you get back a Phoenix reply, and it will tell you, hey, your status is okay, and you are now player X. Your role is X in this game, or your role is O. And then you can also get back some errors, like if the game already has 2 players, we'll get back an error. But then basically you just start getting these state messages every time someone plays, and then you send a move and which square you want to take each time you're ready to play. And you have to send along that token again. And then once that's all done and the game is over, you'll just get a game over message. So it should be pretty simple protocol. There's only a few types of messages. You can go back and read through this, and it covers most of the edge cases. The only gotcha that's probably worth pointing out right now is that people can watch the game. So like from your browser, for instance, you can just say watch game 1 and /tic-tac-toe/watch1. So you can watch a game progress, and every time someone joins the game, the server rebroadcasts the current state of the game. So it's possible for you to get 2 copies of the same game state broadcast, basically. So if you want to write your code so that every time you get a message that's like, hey, it's your turn, just be aware you might get 2 of those in a row because someone else joined the game to watch. But slight edge case, it shouldn't be too hard to work around. The other link on here that is hopefully helpful is that there's a sample Ruby application that was already written that is an implementation and can already play this game out of the box. Hopefully it's a good starting place. So as an example of that, if we go back and say, let's watch game number 1 in the browser here, and nothing's happening, then we can, once you clone that thing and bundle install, this command is in the README, No. But basically, it's just like a normal gem executable. You have to add your lib directory to your load path since it's not actually installed as a gem right now. But basically, you can just say help, and it'll tell you, here's all the commands you can do. You can basically say play a given game ID or loop a given game ID. If you loop, it just basically plays, and once the game is over, it rejoins and plays again. And so it'll just keep playing over and over in a loop. But the implementation of this right now is pretty basic. So you shouldn't have to set the URL. That default one should work for tonight just fine. You can pass in a --AI equals random. We'll see this. That just makes the server start up an opponent for you, which is kind of a randomly planning AI. But once you do that, all it does is it creates this toe tactics client object that's going to join the game. And then every second it tries to make a random move. It doesn't even know when it's its turn or not. It's just watching for a game over message, and then it closes down its connection. And so it's like a super, super naive implementation, but it works. So what we can actually do here is instead of watching game one, let's actually play game one. So I've now joined the game, and if I run this thing and say play game ID 1, over here I can play, and my Ruby script is playing against me now. And apparently I'm really bad at this game. Hey, I won. All right, so you can do that. You could also choose to just watch game one, and if I rerun this thing and just say AI equals random, then the server will just be playing against this, and I'm just watching the game happen. So hopefully that's enough to get everyone started. Take a look at client.rb and this toe tactics thing. The client isn't really using any information right now. It's just logging every message that it sends and receives to the terminal. So hopefully that also makes it clear what things you can look for in these messages. But there is a method right now on message that's getting called every time the WebSocket sends something back to you. And so you could, this is a good place, hint, hint, to like tie in to start to implement some logic for your client so that it's not just randomly trying to make a move every second. So any questions before we start coding?
Can you like post those links in Slack or something?
Sure. Yeah, the main one is just games.rec.com. There you go. And that on that page it has links to the tutorial and to the sample Ruby application. So feel free to grab me if you have questions, but basically we're just going to start coding, and I'm going to leave up on my laptop here projecting, I'm going to leave a few Chrome tabs open watching a few different games. So if you would like to have like an exhibition match, I'm just going to leave, let's say, games UV.rb 1 through 4 up on here. Let's see. Oh, it looks like I can do 6 up here. So I'll just leave 6 of these up here running, and these game channels might kind of get busy. But feel free to jump in there if you want to challenge someone. Oh, there's not enough vertical space. I guess they're just going to do 3. So the UV.rb 1 through 3, and these will just stay up here on the TV, so you can watch your bots battle each other if you're into that sort of thing. Battle bots. Slightly less cool than the ones that shoot fire at each other. Do what you can. All right.